For the arrangement shown in figure, the two positive charges plus q each are fixed. Mark out the correct statements regarding a third charge q placed at a midpoint p that can be displaced along perpendicular to the line connecting the charges. Means there are two charges plus q and plus q. So there are two charges plus q and plus q, and at the midpoint there is another charge. Okay, and this charge can be displaced this way along the perpendicular bisector or this way along this line joining. So since these two charges are positive and the third particle q placed at midpoint p such that displaced along perpendicular or along to the line connecting the charges, the particle will perform SHM for x much smaller than a. So for x-axis if we talk about, so third charge particle q is placed at the midpoint. Since third charge is also positive, so if we see for this particular charge and if we displace it this way, suppose here, then force of repulsion due to this charge will be increased and force of repulsion due to this charge will be decreased because of the greater distance. So net force will be acting on this direction. So when we displace this particle at the center to this side, then the particle is going to move back to the original position. And if we displace it on this side similarly, so in this case, when all these three charges are having the same sign, then this center charge can be displaced along the line joining these two charges and it will oscillate. And if we calculate the force acting on this particle, then we'll get to know that this force is going to be proportional to x only if x is very small in comparison to a. And this is a very popular question. You must have solved this at least once. So the particle will perform SHM for x much smaller than a. Means if we move the particle along the x-axis, then it will perform SHM. The particle will oscillate about p but not harmonically for any x. This statement is also correct because for larger value of x, this is not going to be SHM. Okay, if you want, I can show you the net force. Suppose the distance between these two particles is say 2L, so that we can divide it L, and this particle is moved by distance x. Distance of one particle will be L minus x from this and the other one will be L plus x. So F net is going to be what? 1 upon 4 pi epsilon naught, and the common term is capital Q into 1 upon L minus x whole square and minus 1 upon L plus x whole square. So this becomes capital Q divided by 4 pi epsilon naught into, here it becomes L square minus x square whole square, and numerator it will become 4Lx. So you can see that F net is proportional to x only if x is negligible in comparison to the L. That is why we are saying that it will not perform simple harmonic motion for any value of x. It will perform harmonic motion only for a smaller value of x, which is much smaller in comparison to the a. The particle will perform SHM for y? No. For y-axis it will not perform SHM because these three charges are having the same sign. So as long as the particle is kept at the middle point, it will be in equilibrium. But if we move this particle to the perpendicular bisector, then this particle is going to repel it this way, this particle is going to repel it this way. So net force will be acting this way. So particle will be moved further. So it is not going to oscillate along the y-axis. The particle will oscillate about p but not harmonically for y comparable to a. So this option is not correct because here there is no chance of oscillation along the y-axis. Okay, because in case the charge would have been the negatively charged particle or these two charges were negative, in that case along the x-axis oscillation would not be possible. Only along the y-axis the oscillation would have been possible. Okay, so the same question can be asked in a different way by changing just the sign of the negative, the sign of this particle, making it negative, or just make these two as negative. Okay, then C and D would be the correct option, like the A and B are here in case of same sign of all these three charges. So option A, B are correct.